The LED is 90 now. Hello, welcome back. In this video, we talk about how to ignite the LED using GPIO. In this video, I will tell you how to take connection and how to write the code step by step. Let's go on. This is the structure of the code. The first step, we need to open peripheral clock. In the previous videos, we talk about the GPIO is one of the peripherals. So the first step, we need to open the peripheral clock. And then we need to init GPIO. And the next step is set GPIO high or low to ignite the LED. This is a circuit connection here. You should notice that this is LED. We connect the negative terminal of LED to the PA7 and connect the positive terminal of LED to the power supply. It means that if you set the PA7 low level, the LED will be igniting. If you set PA7 high impedance or high level, the LED will not ignite. Please take this connection. This 3.3 volts is connected to the positive terminal, and this GND pin is connected to the negative terminal. And this one is our LED. The long pin is positive pin, and the short one is negative pin. So let's connect the long pin to the positive and the short pin to PA7. And we plug STM32 to USB. We already done this connection. Let's open this folder, STM32 project, and find this folder, STM32 template project. I already told you how to create this in the previous video. In this video, we directly use this, copy, and give it a new name. Okay, open it. I put the structure of code here. Let's achieve it step by step. The first step is open peripheral clock. So we need to use this field, RCC.H and RCC.C in library field. Let's click this. And we go to below, we will find that there are so many functions here, right? But today we only need to use this one, RCC-APB2 peripheral clock command. In the previous video, I talked about that GPIO is belong to APB2 peripheral clock, right? So we need to use this one to open peripheral clock. Copy to here. There are two parameters here, and we found in field Ctrl+8F and find in OR. Go to RCC.C field. This is the brief introduction here. This introduction indicates that the argument to the parameter. For the first parameter, the argument you can give it is this. Today, we only need to know this one, GPIO A, GPIO B, GPIO C, D, E is okay. And other argument, I will tell you how to use it in the future. I give this argument to this parameter. And for the second parameter here is new state of specified peripheral clock. This parameter can be enabled and disabled. Of course, it's enabled, right? And the second step is initial GPIO. So if you want initial GPIO, you also need to know the field in library. GPIO.C, GPIO.H. So let's click .H. Go to below. This is what function in this field. Obviously, we need to use this GPIO init. Let's copy to main. You need to notice that there are also two parameters here. So let me check it. Ctrl+8F. So found in word. And let's go to there. This is a brief introduction. For the first parameter GPIO X, where X can be A to G to select GPIO peripheral. So I think it's still easy. We use PA7. So we will use PA, right? GPIO A. And let's check the second parameter. The second parameter is pointer of structure. The introduction is here. Pointer to GPIO type defined structure that contain configuration information for specified GPIO peripherals. So if you want to give argument to this parameter, the first one you need to define a GPIO init type defined structure, and then give argument to the member of this structure. The next step is convert the structure to the point of structure. So let's do it. The first step, we need to define a GPIO init type defined structure. Give it a name. If you type this point, the cal file will automatically show you the member in this structure. Let's choose one by one. So this is a question here. What value should be given this member in structure? We can check it. Let's find this in files. This is the member in this structure. Let's check the first one, GPIO pin. This parameter can be any value of GPIO pin defined. So where's the GPIO pin defined? We can find this one. This is GPIO pin defined. We use PA7, so we need to use this. So the GPIO pin is equal to this one. And then let me check the second one, GPIO speed. And this parameter can be a value of GPIO speed type defined. So let me find in field GPIO speed type defined. There are three members here, right? 10 MHz, 2 MHz, and 15 MHz. We often use this one. Let's copy to here. And the last one is GPIO mode. This parameter can be a value of GPIO mode type defined. Let me find in field. This is the 8 GPIO modes. I already talked about it in the previous video. In this video, I will use this one, output, push, and pull model. And the last step is we need to convert this structure to the pointer. Until now, we finished the second step, initial GPIO. Let's set GPIO high or low. We need an infinity loop. It means the MCU will always run the code between these two brackets. And I also need to use the function in GPIO point edge. Let's go to below. You can see that there are two functions here, GPIO set bit and GPIO reset bit. The set bit is used for set high level, reset bit used for low level. So I need to use this one, reset bit, to net LED. You can see that there are also two parameters here. This one is GPIO X. X is mean between A to G, right? So I use GPIO A7, so this one. And about second parameter, if you don't know how to write, you can find this function in GPIO point C. Here. And this is a brief introduction here. The second parameter can be any combination of GPIO pin X, where X can be 0 to 15. So we copy this one. We use PA7, right? So it's okay. Build and download. Okay, the LED is 90 now. For now, you already finished our first code. If you want to improve our code to net LED blinking, we can continue to write code. If we want to make LED blinking, we need to use a function of delay. I already done this for you. Maybe it's a little bit difficult for you. So you can copy this and directly use this. Copy this code to here. Yeah. And then connect this one. STM system. It fail. Okay, it has added to our project now. And we connect this one, delay point edge, and use this function, give it a number. Oh, there are warning here because we need to include delay point edge. Oh, there is error here. It's because of the pass-off system has not added to the CAL5 working path. So we connect this one, and then connect this one, connect this one. The system folder has already this, but maybe not available. We delete, and then connect this one. It again. Choose this one, system folder. Okay. Now, the error is not shown. No error, no warning here, and we download into MCU. The LED is blinking now, right? I give you explanation about this code. This function is used to set the low level for PA7 and delay 500 ms. The pin of A7 is set high level, the LED will turn off. And delay 500 ms again, the pin of A7 is set low level again. And doing this infinity loop here. Okay, this is today's video. Please program this code by yourself again. Thank you for your watching.